Hi guys, today we're doing search insert position. So we're given a sorted array of distinct integers and a target value, and they want us to return the index if the target is found. If not, then they want us to return the index where it would be if it were inserted in order. And they tell us we must write an algorithm with an O of log n runtime complexity. So in example 1, we're given this input array nums and target equals 5, and we would output 2 because 5 is found in this array at index 2, because this is 0, 1, 2. In example 2, we're given this input array nums and target equals 2, and output we would output 1 because, so we don't actually have 2 in this array, but if we did and maintained it in sorted order, then it would be at index 2, or I mean index 1, sorry, because this is at index 0, and then 2 would be between 1 and 3, which is at index 1 here. In example 3, we're given this input array nums and target is 7, and we would output 4 because 7's not in this array, but if it were, then it would go right after this 6, which would be at index 4 because this is 0, 1, 2, 3, and then 4 would be right after 6. So because we need an O of log n runtime, and it is a sorted array, then we're going to want to use binary search to achieve that. So for binary search, we need to keep track of the low, the high, and the midpoint. So we'll start the low at 0, and then the high at the last element, and the midpoint is going to be the halfway point of those two. And if you guys know how binary search works already, then you can just skip this part, but because I'm just explaining that right now, basically. But so if the target that we're looking for is the midpoint, then we'll just return that midpoint because that's the index of it, like it was found, just like in example 1, right? Like if we find this at the midpoint, then we'll just return that index. If not, then we need to check if the number here is, so like in example 2, we need to check if, so like the midpoint would be like 3 for this one because it's an even number. So if the midpoint is greater than the target, then we know it's going to be on the left side because since it's sorted, then if this number is smaller than the midpoint, then it must be on the left side. So we can just cut out all of the elements to the right of it. And if not, like it's greater than the midpoint, so like in example 3, target is 7, which is greater than the midpoint, which would start out at 3, then we can cut out the entire left side of the array because we know it's on the right side. So yeah, now we can get to work. Basically, then we'll just return the index, and then if we don't find it, then like in here at all, then we're gonna need to return the index that it would be at, which we'll get there. But let's start coding. I will copy and paste example 2 because since, like, I think example 1 is a little bit easier to look at. Like, it doesn't cover the case where we don't find it, so I'm going to use example 2 instead. Okay, so there's our indices, and then we need to initialize our low and our high and our midpoint. So low, we start at 0, high, we start at the length of the array minus 1 because that's the last element. So that's 0, and that would be 3. And then we need to initialize our midpoint, and I'll just leave that for now because we're gonna need to redefine it in our while loop. So basically, we're gonna keep looping while our low is less than or equal to our high. Because once they've reached the same, then that means we've like searched the entire array, basically. So we're going to initialize mid to low plus high minus low divided by 2. And that is because, like, this is just like a safer way to calculate the midpoint for binary search because if we just do low plus high divided by 2, then sometimes it can cause like an error. So it's just like a safer way to do that. Okay, and then now we need to do all of our checks. So if our number at our midpoint is equal to our target, that means we've found the target number, so we can just return mid because that is going to be the index of that number. And if not, so in example 2, our target is less than the midpoint. So if target is less than the number at mid, then that means we need to cut out the right side of the array. So by the way that we would cut out the right side of the array is by setting high to the midpoint minus 1. And then otherwise, so if it's not the low, if it's not, if the midpoint is not equal to the target and the target's also not less than it, then it must be greater than it. That's the only other possibility, which we see in example 3. So if in this case, then we just do the opposite. So like, since we're cutting out the left side of it, we're gonna cut it out by setting low equal to mid plus high. Mid plus 1. Yeah, just like that. So let's just like run through this real quick before I get to what we'll return at the end if we don't actually find it, because this only covers if we find it, then we'll return it in the middle of our loop, right? But like if we exit the entire loop and we didn't return anything, that means we didn't actually find the target in the array. And so that is going to be like, we're going to have to figure out what to do in that case. So we start out with low is 0, high is 3, mid is going to be 0 plus 3 minus 0 divided by 2, which is just 3 divided by 2, which is going to be 1 if we do integer division. So the nums at mid is going to be 3, and that is not equal to target, because our target is 2 for example 2, because I'm going to just use example 2. So it's not equal to target, so we move on. Our target, which is 2, is less than nums at mid. Nums at mid is 3. That is true. So our high is going to be the mid minus 1, and mid is currently 1, so high will become 0. So this becomes 0. Okay, and then we don't do this because we already did this one. So the next iteration, low is 0, which is less than or equal to 0. So we'll still continue. And then our mid will be low plus high minus low divided by 2, which is going to just be 0 plus 0 minus 0 divided by 2, which is 0. So then the index at nums at mid is not equal to target, because nums at mid is 1, target is 2. So we don't do this. We move on to the next one. Target is 2. So is 2 less than 1? No, it's not. So we move on. Then low will become mid plus 1. So mid is currently 0. So our low will be 0 plus 1, which is 1. And then now low is greater than high, so we exit out of the while loop. And then, so now if we think about this, then what are we returning? Well, if we think about where target would be in this array, it would be at index 1, right? Because it would be between 1 and 3 here. So we can just go ahead and return low, because low is the index that it would be at in this case. Because remember, mid is 0, high is 0, and then low is 1, because it goes 1 past the like last element that we just checked, if that makes sense, which is where the target would be if we didn't find it. So we're going to return, if I can type, low. So let's check that. Okay, perfect. And then our time complexity and space complexity for this one should actually be pretty straightforward. Time complexity, they literally tell us right here, it's just log n, but let's still cover why that is. So n is number of numbers in nums. That sounds like a tongue twister. Basically, the reason why it's log n is because in binary search, every single time we iterate through the loop, we are cutting out half of the elements in the array. So by every time cutting out half and then half and then half, then that's basically a log runtime. So anytime you like continuously cut your input in half in your time complexity, then it's usually going to have like a log like that. So space complexity is just going to be constant, and that is because we don't have any data structures here. We just have some variables which are constant. So that is it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. Bye!